What if chain-of-thought reasoning in large language models isn't just linguistic prompting, but actually a clustering algorithm in disguise? A recent framework called KCOT proves exactly that, fundamentally changing how we approach reasoning on text-attributed graphs. The core problem with current graph-COT methods is architectural disjoint. LLMs and graph neural networks are usually chained sequentially. The LLM parses text in isolation, while the GNN handles topology separately. This prevents step-by-step semantic topological interaction, creates misalignment between reasoning and structure, and leaves the process as a black box. KCOT solves this by establishing a formal isomorphism between transformer blocks and k-means clustering. The authors prove that by carefully constructing the query, key, and value projections alongside a key-dependent attention bias, a single self-attention layer can exactly replicate the soft assignment step of k-means. The attention weights become cluster assignments, and the value outputs act as centroid updates. Instead of treating this as a hidden property, KCOT externalizes it through a semantic discriminating prompt. The prompt explicitly forces the LLM into two iterative phases. First, assignment. The model filters out neighbors with low similarity to the target. Second, update. It performs abstractive summarization to compress the retained information into a dense paragraph, which mathematically functions as the new semantic centroid. To anchor this reasoning to the actual graph, KCOT retrieves neighbors from both the fixed topological neighborhood and a KNN search on the evolving representation space. A lightweight condition net then fuses these signals into a reasoning matrix that modulates the node features for the next iteration. Theoretically, each COT step geometrically contracts the semantic structural misalignment, stabilizing message passing and preventing cross-class contamination. Across standard benchmarks, this clustering-grounded approach consistently outperforms state-of-the-art baselines on node classification and link prediction. By replacing black box prompting with a principled, iterative alignment mechanism, KCOT finally gives us a geometrically interpretable path for reasoning over graphs. If you're working on graph foundation models or LLM reasoning, this is a critical read.